Hi everyone, and welcome to this explainer video for one of my portfolio projects. So I got into competitive jigsaw puzzling at the same time as I got into coding, so I thought this would be a perfect piece to put in my portfolio. Uh, Unlike regular just doing a jigsaw, competitive puzzling is all about speed, and usually do a 500 piece puzzle and fastest person wins. Now I wanted to create tools that would help me train, but also I'm wondering one day whether I can actually create a robot that'll be able to do everything for me. So that'll be like a super cool project down the line. But for now, what I did was create a puzzle cheat sheet. Now, for those not familiar with how jigsaws are produced, what usually happens is you take a photo, you stick it onto cardboard, and then you get a cookie cutter like blades, and then you simply cut the puzzle. And so because these cookie cutters are quite expensive, you're actually using the same cookie cutter over and over again to produce your production run. And if you know what that cookie cutter looks like, or should I say, if you've done one previous puzzle from the same company before, you can actually use that completed puzzle to give you an idea of what a future puzzle from that company is going to look like, because like I said, they very rarely change the cookie cutter. Now, in order to create this cheat sheet, we need to do this in 3 steps. We need to deskew the picture on the box. So that's going to be used for, let's say, the background layer of an image. And then we're going to generate a puzzle cut in step 2. And then step 3, we're going to have that background layer, and then we're going to paste the puzzle cut on top of it. So we're going to merge the 2 images together. So deskewing the picture on the box. Let me open up my script for that. Actually, before I jump into that, let me show you input of what we're going to have. We're going to have this picture on the box, and eventually I want it to look like this as a completed cheat sheet. As you can see, I've got my grid and I've pasted it on top of what was initially the picture on the box. So first thing I did was I had to figure out, let me actually just run the script. So I wrote this script following a tutorial. Let me run a Shift Control B. There we go. It's taking the original image, and then it's asking me where the corners of the picture are that we're going to deskew. So I'm just going to click here. And every time we click here, what it's doing is creating a circle at that spot. And it's also adding those coordinates into an array that's going to help us with the deskewing. So 1, 2, 3, 4, and boom, it pops out the image, which is really cool because what it's not doing is doing edge detection and stuff and trying to automatically guess what the picture is, because that's going to fail. So let's say I did actually want to take the picture, deskew the picture of the whole box. Let me run that script again, and I can go over here, 1, 2, 3, 4. Oh, it's going to be off the thing, so maybe we won't be able to do that. 4, and you can see it's got a bigger image. And so I thought that'd be easier to do it manually than automatically doing edge detection and kind of get the image that way. So we've got step 1 done. Quite easy. Step 2 was the brain racking part of the project, because we wanted the grid of the puzzle, and obviously you can't just find these images online, and you can't take an image of an incomplete puzzle. And so what I actually had to do was complete a puzzle. Let me show you. Flip it backwards, take a picture, turn it into high contrast so I actually could see the image. I could see each individual lines, and I could see each individual piece. And so with that, I was like, okay, I've got to basically transcribe, I've got to do data entry. So obviously my computer can read what the puzzle is. And this was like, how do I do this in an efficient form? So if other people are doing this, or if I want to do this for other puzzle cuts, it's going to be quite an easy process. Now, it got me thinking, okay, maybe I can try to identify each of those pieces, like those piece types, because there's only 6 types of jigsaw pieces, and then I've got to figure out what rotation they're doing. But then when you do data entry, you don't necessarily do calculations, right? You don't be like, okay, let me identify what this piece is. Okay, this is piece type number 4, and it's facing west. It's just too much work when you're data entry because you're stopping and starting and stopping and starting. And so what I want to do is like, how can you interpret this image in a more data friendly way? And what I figured out was, hey, instead of trying to figure out what each piece is doing, let's try to figure out what each edge of those pieces are doing, because it's much faster for me to, for example, be like, oh, this piece edge is facing left, 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 right, left, right. And then also for the top and bottom edges, it could be like up, up, down, 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 down. And so that's much easier for me to do data entry on that. And so what I need to do was then create these edges. So I just simply got my preferred Photoshop program and I just drew this with lines. And then I started transcribing, and you get something like this, which is a txt file, something very easy for Python to read. And then using the Python image library, I could take all these small images of the edges, create a canvas, and then, so over here we can go back to the code. What we're going to do is we're going to read the text file. We're going to figure out the length of the columns and the lines. We're going to create a canvas based on that. So we're gonna well, first we need to know what the standard dimensions of each size is. So I created an image of what a standard piece should look like, the size of it, and then we created the canvas. Using that information, we know, okay, our DNA is telling us that we've got 20 pieces wide and we've got 25 columns, and so that's how big we want to make the canvas. We load up all the edge images and then we paste them. And so when we're pasting them, it's kind of like, okay, read the first thing, paste here, increase the counter, so we know we want to paste over here, increase the counter, paste over here. And once we get to the end of our counter, to the end of the line, we're gonna, like almost like a typewriter machine, we're gonna go back, we're gonna go down a little bit, and we're gonna start here. So every time it reads the piece, it's gonna paste the corresponding image, go back, paste, and at the end of it, we've got this awesome grid over here. So I was quite proud when I made that, because yeah, it's kind of cool. Like now I can basically read any picture, type it up, and boom, we've got an awesome grid. So step 2 complete. Now up to step 3. This one probably was one of the easiest steps to do. It's image merger, but then I realized after I did this, it's not so obvious. Like, the more and more I did jigsaws, I realized the image on the box isn't always the complete image. In the sense that the grid, the puzzle, doesn't actually start at the corner of it. Sometimes it's a little bit in, sometimes the picture is a little bit zoomed in, zoomed out, and so shift to the left, shift to the right, and so I need to type in those variables in post after I've already taken the Deskew image of this and then adjust it. We've got a background image then using all those variables. So if you come into the script here, you can see I'm taking in how much we want to zoom in by, taking in how much we want to shift to the horizontally, how much we want to shift vertically. We're opening up the images. Image A is the Deskew image, image B is the grid, and then what we're doing is we're zooming in. So this is a bit of a pain for trying to figure out how to do it, because once we zoom in, so let's say I want to zoom in twice, right? So I'm going to make the image twice as big, and then I'm going to take a crop, and so we've got our zoomed in image. Then the next thing we've got to do is to shift, horizontal shift and vertical shift. So the way I figured out that, again, what I'll do is I'll increase the canvas size. So if we're shifting by this much, I'll increase the canvas size by this much, and then what I'll do is I'll recrop it. And so that's how I figured out how to do that. So now we've got a background image, and then we simply got to paste the grid on top. So that was the easy part. Save, and now we've got our results. And so if I open up some of the tests, so we've got original box image, deskewed image. This is the first result before I realized I need to zoom in and crop. This is the zoom in function. You can see that, and you can see over here in the previous photo, you can see that there's a bit of a bleed. So we want to get rid of that bleed by shifting vertically and horizontally, and we've got that. And I was like, all right, what if we want to go the other way? What if we want to zoom out instead of zooming in? Well, that worked as well. And yeah, so quite happy with what we ended up with. Now, this was a bit of a flex on learning how to do a bit of Python code, but if I want this to be a product that can be used in actual daily life, I need to turn into an Android app. And so that's going to be what I'm going to be learning. Yes, I'm learning the Kotlin language using Android Studio, and hopefully I can apply all these Python scripts of what I learned from here into an Android app, and then on the go I can just take a picture of the box. I can take my saved piles of my previous puzzle cuts, just apply them, and hey presto, good to go. So thanks for watching. I'll see you at the next video.